Thanks for joining us in this talk. So I'm very nervous because it's my first presentation in English, so be patient. My name is Joaquin. I work for Spider Labs in Latin America. Ulysses is lab manager to Spider Labs. So agenda. We're talking about introduction, motivation, background, how stuff works. The microfiche. The microfiche is the tool. We developing the tool with.
The tool we developed.
Isso aí. Then future work and conclusions. So. Okay. This talk describes well-known techniques that can be used for bad guys to create a more sophisticated spear phishing to attack the companies. So we're not bad guys, okay? So okay. Here we not show the new techniques. To create a spear phishing. We know we talking about the tool with.
Okay. So the tool we developed does not innovate in the terms of the technologies it uses. We do basic data collection, filtering, and natural language processing. And the thing is, we combine all of that. Okay, sure. And we combine all of that in a way to produce a workflow which allows us to feed on social network data in order to produce profiles which can then be used to help a user forge content which looks very similar to the profiled user would write. So that's what the tool does. And I think the point Joaquin is trying to get through is we are not really focused on this tool, on innovating on any of these individual fields. The real innovation here is in the way the tool combines all of those and in the purpose of the tool itself, which is to support ethical hackers and to support, we also have a defensive perspective on this because the same metrics and the same kind of feedback we provide on the text input you give us as compared against this profile can be used either to validate if it looks legit and to be used in an attack or as a defensive measure when you suspect some content that was sent to you and you can try again and validate that same content against a known profile in order to validate whether it came from some person you have previously profiled or not. Okay? Right ahead. So as I said, our motivation is exactly that. As security consultants, in many situations we are faced with issues of gaining access to systems which are really tough to crack when coming to the traditional ways. So sometimes you need the support of social engineering, right? But if any of you do consulting work, you know that sometimes projects are way shorter than they should be. And sometimes you don't have the time to actually go and build an adequate profile using intelligent gathering and, actually understanding the identity of someone you're trying to impersonate when doing a social engineering attack. So we built this tool so that we do not want the user to worry about understanding behavior. We don't want this person worrying about understanding who that person is, who their particular interests are. We don't want to focus on that. We just want to make the content looks like it came from that person. That's the main difference from our approach to a lot of the things we have on the market today and a lot of the services some companies offer, which is they're mostly focused on intelligence gathering. This is not an intelligence tool per se. It's mostly focused on appearance, right? Because for most users, and in social networks that's particularly true, if a content looks legit, we are very quick to click on a link or to open an attachment or do stuff like that. Social networks in particular This happens a lot because we use that on smartphones, we use that a lot in environments where we're more laid back and when we're more relaxed, and then we tend to forget all those things that we've been told tons of times about not opening links, not clicking on suspect content and stuff like that. So we'd like to provide some background in order to try to give a better understanding of our approach and how it differs from traditional approaches to social engineering and profiling due to the specificities of social networks, right? So, regarding social networks themselves. First thing is, tons of them out there. And many of them are built for completely separate purposes. So, you have Twitter, where in many situations you will have these high-profile people which will have thousands or even millions of followers that will retweet whatever they say whenever they say it. Sometimes you have stuff like Facebook, where you have users who are closely, I think Facebook is probably the thing that most closely resembles what we refer as friendships in real world, right? And then we have more specialized social networks, such as Foursquare, GetGlue, LinkedIn, which are focused on more specific needs. It's either professional, it's either geolocation, or for instance, GetGlue is more targeted towards media, what movies you're watching, what music you're listening to. And the thing is, not all of those social networks provide content which is interesting when we use it for social engineering purposes, because many of those will provide little to no control over the actual message delivered by the user. So when I do a check-in to a mover, say in GetGlue, I am allowed to provide a little message, but most of the content of the actual check-in is provided by the social network when it says, my user is now watching the move X, right? Or same thing with Foursquare. When I check into a place and I don't provide any additional message to that, the content is entirely generated by Foursquare itself. And it would say that Ulysses has checked in at place, whatever. So for our purposes, that's pretty much useless because that's the same for every single user out there. It does not give context, and we're talking about spear phishing. Spear phishing is all about context. We have to provide some message that will make the user believe that it actually came from the person we say it came from. Right, so, no, you can go back a little, no? Okay, no, so go right ahead, sir. So there's also the overlap of social networks, which is an issue. A lot of social networks allow you to link accounts so you can publish status from one social network to the other. For instance, when you do a check-in in Foursquare and have your Twitter account linked to that, it will post a tweet saying, you have checked out in this place, right? And we'll talk about this later on, but the main issue with that is you cannot use then that source as an authoritative source of user-generated data, because you now have a lot of content that was not actually written by the user. It was posted on their behalf by these other social networks, but will show up in their timelines as if it was written by those users. So we have to filter those out. We'll talk a little about that later. So we mentioned that, yeah? And the purpose of the end purpose of our tool, phishing, right? Phishing in the traditional sense is pretty much, throwing a bait, see if anyone bites. That's where the term came from. Spear phishing, more targeted phishing, something that's not really like throwing it out for any specific user, but rather throwing it out for a very specific user or a very specific user profile at least, right? So this is what we're talking about here. Social networks can help us in that regard because in a lot of scenarios, and this already happens today, sometimes you will trust stuff a little more when, say, you get mentioned by someone directly by your user ID on a social network status update. I don't know if any of you got that already, but it's quite common as used by some people to gain followers. So they will post random garbage and then mention a lot of random users in their tweets. So you eventually click on their profile to see who is this guy who's mentioning me. And that could lead to a bunch of other consequences, right? So that's what the kind of thing we're talking about here, which is trying to give more context to that. So instead of looking like it came from this random person who mentions you for no particular reason with a nonsense message, we want to make it look like there is a legitimate reason, and we want to provide the two. We want to provide you with a tool that helps you support writing content in that way. Okay, so the data pre-processing, what is it? As we said, tons of data sources, right? These data sources, some of them interesting to us, some of them not. Also, in Twitter, which is what our tool right now is tailored for, there is the concept of retweeting, and then retweeting has two distinct modes, which is native retweets and quote retweets, which they used to call old-style retweets, right? So when you're doing what with Twitter call a native retweet, you can actually obtain the information that content was not originally written by the person and the timeline it's appearing on, right? So you can see that, okay, this is something else being quoted here. But for old-style retweets, right, or quote retweets, you actually prefix the message with an RT, a mention to the original user, and then the content. And the problem with that is that sometimes people will add content to the end of the message. Sometimes they will alter the original message so they can fit their message appended to the original message, right? And dealing with that kind of scenario in an automated way is extremely hard, because that's free-form text out there. People use different kinds of formatting. People use different. They will also sometimes abbreviate words. When we talk a little later about natural language processing, we will see that that breaks a lot of the stuff we try to do when doing analytics with the words the user would use. So we do a lot. We provide an interface where the user can do a lot of data filtering in and pre-processing in order to guarantee that the actual data that gets indexed and builds the profile and the dictionaries and all the data structures used to support the production of content are based off good data only, and not just random data sources or random social networks or quoted content mostly. So this is how we do it today. Okay, so we have the raw data set, and that would be like the message there. Had lunch with, that's my user, you are MA, and J. Spinara is Joaquin, right? We have hashtags. Hashtags are particularly important because hashtags is something that the user wants to specifically categorize the content on. So when I use a word without it being a hashtag, and I know that sometimes we abuse that, but the intended purpose of hashtags is that we would provide a way of adding a tag to the message so that we want to explicitly indicate that it's about some topic or some subject or some, and we rank those differently than we rank regular words. Because that's the user explicitly stating, okay, this message is about this. This is different than the same word appearing without being tagged. So we do the cleaning, we extract that, we use that separately. We'll show you in a few minutes when doing the demo that the Twitter API provides a very clean and very nice way of us to handling that, because they already index all the hashtags, all the user references, and all the URLs present on a given tweet. So I can remove that from the text content, and then I can have that back from the metadata that I get back from Twitter using their official APIs. Right? So for the text processing part of it, we remove the hashtags. Next thing is we have to understand what inside that content is particularly special. In the case of Twitter, that would be user references, right? So if you receive a message that mentions a user as it came, so say, Joaquin mentions me in a message, that's common. Joaquin mentions someone else he's never talked to, and you as a follower of him never even heard of. That will raise a few red flags. So this is also something that is used on the ranking of messages, which is like we check for all references and index content to given users, to a given set of users, and then we validate that against this dictionary of users we built based on this. And finally, we add temporal references. So like the today in that message, it refers to the day the tweet was actually posted. It's not today as the day the message is read. It's today as in the day the tweet was posted. So we also have to understand that. We do that on the actually this is not even on the data preprocessing, this is done later on the NLP part, on the natural language processing part, on which we have the adverbs for time and stuff like that. We compare that to the time references and then we index this in a timeline. I'll show that in a little bit. Okay, so NLP. So NLP basically is the processing of natural language content, right? So we didn't try to do that. That's a hard problem, real hard problem. We used available libraries for that. We actually use a library called Treat, which is a thin wrapper around the Stanford core NLP library. And the real hard thing about NLP for social network content is that first, there's a lot of content in social network, text messages, so textual content, which is not really words. So URLs, user references, and hashtags are just an example of that. But sometimes you get additional stuff, like say, sometimes you get abbreviated words, sometimes you get acronyms, and sometimes, especially with younger people, they will cut out vowels, they will abbreviate words to completely meaningless abbreviations that we can't really address with traditional NLP. There are efforts in trying to expand the NLP parsing abilities of existing tools in order to better support that, but we couldn't find a library that provided all the available metrics we need to use, combined with good support for, you know, SMS-like text input. So there's very little out there that will do the kind of stuff that Treat does for us today, and also handles well abbreviated words, words without vowels, acronyms, and things like that. Okay, so this is, let me check the time. Yeah, we're rushing a little bit, but it's better because you can see the demo and see how this actually looks. Okay, so, okay, yes, I'm interfering right now. Okay, so how this works. Some of the concepts we built. First thing is, we need someone to profile. We call this an unknown subject, unsub. Anyone who watches Criminal Minds have probably heard the term before. Based on that, we then provide a list of social network IDs we can use on that person. The tool today supports more than one social network ID, but the current implementation is Twitter only, right? So you can have multiple Twitter accounts linked to a given subject. Sometimes that will happen a lot because, especially in corporations, people will have their individual or outside work IDs. They will have their corporate identities. They will have sometimes they handle social media for the company, and they will have multiple accounts. And even if they sound like they express themselves in different ways through those identities, they cannot really hide the specificities of the way they write. So for instance, there are tons of studies that say for example, that men tend to use more adverbs, women tend to use more adjectives. And this kind of thing will show up when profiling content written by those people, even if they try to be more formal when writing content under corporate identities, or be more relaxed and laid back while writing content under their personal identities. Right, so you can't really hide these kinds of things because they're very much ingrained in the way we tend to act as human beings. When we do this collection, the current implementation uses the official APIs. We also consider doing scraping. Thing is, most applications today are very much resistant to scraping because, first, that would mean that people would be feeding off their content without an explicit ID or an explicit identification of who is behind that crawling effort. That can't happen when you're using the official APIs because you have to use social network issued application ID and user ID when doing all the data gathering. So they know who you are, they know what is your application, and they know what's exactly the data you're fetching off them. That doesn't necessarily happen with scraping, so most social networks, they tend to be very resistant to scraping the HTML for user content. Also, there's the issue of authentication. One thing we were worried about while writing this too is that sometimes people will protect their content, right? So if you use Facebook, Facebook has tons of knobs and switches and anything in order for you to protect your information. A lot of people don't understand how that works, but they are there if you do understand. With Twitter, you can actually protect your tweets. So if someone tries to follow you, you have to authorize them in order for them to be able to see your tweets. Other social networks also provide similar controls, but the point is, if you are already authorized to see content produced by a given person, we wanted you to be able to. And the only way to do that is if in some way the application is able to use your identity when talking to the social network, right? When we're talking about the official APIs, we'll talk that in a little bit, that means OAuth. Right? So OAuth is that thing we will show you a little bit in the demo. That little thing when you sign in with Twitter or you sign in with Facebook, and then you're directed to their page, and then you will confirm that you allow this application to use your identity, whatever, and then you get back to the application. And when you do that, you're basically giving that particular application some right over your data on the social network side, right? And that's a very clean way for us to handle the issue because we don't ever touch the credentials of the user on that particular social network. Scraping wouldn't give us that option. If we wanted you to be able to fetch content which is protected under a social network but is available to your user on that network, we'd have to authenticate on that network as you. And that would mean necessarily logging in as you, which involve obviously your username and password. We don't want to touch that. Right? So right now, the current implementation uses OAuth for that reason. Finally, we do the analysis and we build the profile. The analysis today, not much control over how it's done. The user will simply start the process. It runs in background. It can take quite a while. The way the application is built today, that's one of the things we need to focus on the future performance. But after it's done, we will show you in a while, you have a tree of all the words, sentences, terms, and everything that you use, the frequency you use them, and then based on that, we will provide you what we call an assisted textual input interface, which is pretty much to say an autocorrect on the web for you to write content which will suggest words based on the dictionary built on user content, right? So, an unsub, we mentioned that already. The idea is that in the future, it will be able to use multiple social network IDs from different social networks. One thing to note is people will write content differently on different social networks, mostly because they are focused on different purposes. Right, so Twitter in particular has a 140 character limitation, which will make people look like they are trying to cram a lot into very little space. But when dealing with other networks that don't have this particular limitation, this starts to go away and people try to write more naturally, and the thing and the tool gets a little bit more effective in that scenario. So we mentioned that already. What Phisher does, our tool, is to link an application ID, and we will show you that this application ID today, despite it being associated with a given instance of Phisher, is something that any one of you with a Twitter account can get on Twitter anytime. You just have to go to their development site, request a new application to be registered. They will give you the OAuth application keys. You configure that on your Phisher installation, and then you have a completely new, brand new Phisher instance. That is nice for us because it doesn't we considered hosting that and providing it as a service, but then we'll have a single point of failure where Twitter could basically block us anytime they wanted, or any other social network which uses OAuth, basically. So the thing is, this is a little web application that will run on your computers, and you can get yourself a separate application ID for every instance you get it running. So, okay, so Phisher, what it is. Phisher, as we mentioned before, was supposed to be our reference implementation for this particular concept, right? It serves two main purposes: validate potential unknown subject content, that's the defensive perspective, that's validating something provided by a suspect source against a profile we already have, right? And what we think is the main innovation in the tool, which is the assisted textual content input, right? So the assisted textual content input will basically provide you tons of metrics, not really tons, but some metrics in real time while you're entering text, and it will also suggest you words that are most commonly used by the subject. And just so we can show how it looks like, this is how it looks like today. So we have Luis, who is in the audience, and we have Nick Pecoco, right? They were our guinea pigs for this experiment. So Luis has the user Effin on Twitter, right? And I have 3,240 tweets from Luis in this database. The oldest one is about 2 years old. The newest one is 11 days old, right? The indexing for this is complete. Of course, we are offline here, so it wouldn't be indexing at this time, but this whole process is done in background because it can take a while. There's also the issue with rate throttling on Twitter, so you can't issue too many requests on a short period of time. If you do that, they will start throttling you. If you insist on doing that, they will eventually block you. We had both scenarios already happening, so we didn't want to risk it. But we have, let me just, yeah, that's better. We also have a profile on Luis, which is beer mentions. So this is actually, we'll get back to that in a little, this is actually a MongoDB query, which is used in order to filter out the tweets in our local database we are interested in. So that's anything that has beer, starting with a capital or not B on the system, right? And which did not come from Untapped. That was actually an issue when we were doing our experiments because a lot of the InfoSec guys in our circle of friends, they use Untapped. And Untapped is basically a social network for beers. And there's a lot of references to beers which came from Untapped. So, but we filter out here, right, Untapped, and then we want anything that has to do with beer. That gave us 257 tweets with an average of 12 words per tweet. And because Luis is a Brazilian guy, there are some outliers here. So like tomei is a Portuguese word, chamou, right?
But for Nick, now why that? Okay, no, that's the wrong place. It's here. So mentions the trust wave here. Same kind of syntax. Anything that mentions with trust wave in the text and does not contain an RT at the beginning of the text, right? So that amounts to 17 tweets with an average 17 words per tweet, and these are the most commonly used words, right? So this is pretty much what it looks like. It's very, very simple, as you can see. The fun part is this one, right? So, okay, so let me just get back here. Top 10 words for tweets Nick sent from his iPhone are epic win, tag, karma, prime, hashtag, feel, search, immunization, deceitful, right? So if I forge input based on this, and I put an E here, you will see that the first suggested word here is epic, which has a word frequency. This is like a normalized word frequency. For those of you familiar with NLP, that's like TF, IDF score of this thing based on the whole collection of tweets he has, right? So you can see it ranks way, way above anything else that starts with an E. Here you can see my lack of design skills. So the thing is very ugly, but the point is it's quick. And the idea is that exactly that is how it's supposed to happen. You're writing content here, right? And you want to be able to experiment with the words and the phrasing as quickly and as in the more flexible way you can. So when I start writing the P of an epic or the F of effective, right? You will see that also these four ranks here, they will change as we write it. So for instance, since I have not written a word yet that appears on the dictionary it will have built for Nick, that means the word usage rank is 0 because no known words are showing up. If I finish writing the effective, the word usage will go up to 100% because we're using 100% words he used before. Right? The word count here is 0 because the average number of words he would typically use is 17. We are using just one, so basically we decided that, okay, if it falls below a third of the average or above 5/3 of the average, we zero them out. Otherwise, it's moved out in like this bell curve in the middle, right? And the user references here, so if I start something with and that character, it will list all the users that Nick has ever mentioned in his tweets. And here, himself, Spider Labs, Trustwave, ThoughtCon, right? Luis is probably here somewhere also. Yeah, Luis is here, effing. So, the user references is now 100%, okay? And the hashtag references go the same way. If I start writing a hashtag and it doesn't show up in his list of known hashtags, then the hashtag reference will go down. These things are divided by the amount of appearances they have in the text. So if there are 2 hashtags, one of them is invalid, that would go to 50%. That's pretty much how it works. It's very simple, and the idea is that it's simple enough for you to be able to understand how these metrics would go so that it can help you complete this thing in a way that makes sense. The point is, for forged content, you will never typically get 100% in everything, because if you do get 100% in everything, that means that you used only words, references, URLs, anything that the original user produced, right, at some point in time. So you're basically copying him, and you're not achieving your purpose of actually producing a phishing message, right? So, but let's go back to our regular presentation. So that is the assisted textual content input. As you just saw, Micro-Phisher is a web application. It's reader only for now. It's open source, right? It's GPL v3. We use these components on the back end. It's a Rails application. It uses MongoDB plus Mongoid, which is an object relational mapper. We use the lay job for background work. We use OAuth for the actual authentication. So when talking to Twitter, and I can show you a little video if we have, I think we will have the time later. You will see that when it does authentication with Twitter, you only provide your credentials to Twitter, and then you get the token, and you go back to the application the way it should be done, right? And we use Treat for NLP. Treat, as I said before, thin wrapper around, stands for NLP core. Works very, very well when you're using regular words. Does not work that well with abbreviations. That's one of the things to do in the future, getting back to the Treat maintainers and eventually to the Stanford NLP core maintainers in order to add support for dictionaries which reference those words that people will tend to use on social networks, right? So the entire flow works like this. The authentication we already mentioned. Everything that has to do with registration is basically like a CRUD interface. So when you register a new unsub, you just provide some basic information on them. Data cert registration, you link that to a Twitter account or to more than one Twitter account. After that is done, the application will automatically start fetching tweets from those user IDs you provided. When that is done, then you can actually create what we call a work set. So going back to the interface, a work set is exactly this. And this one will show you guys how my lack of skills is even better than you. So this is how it looks like. So say I want to check anything that Nick, that will give us the tweets themselves, where it came from, when it was published, the user ID, because since we only have one user assigned under Nick, all values here will be the same, but when we have multiple Twitter accounts associated with an unsub ID, those will be listed in here, right? And it's not, as you can see, and as expected, most TrustWave references will show up either in tweets that Nick wrote himself or retweeted from corporate TrustWave accounts, or it would come from social networks targeted toward professional relationships, such as LinkedIn. This is what we would expect, right? But if I change that, again, to our beer example, then you will see that, for instance, Untapped starts showing up a lot, right? And the point is, we, at this point, can't really help the user because we don't know what kind of behavior of the unknown subject you're trying to mimic. The idea is that we will eventually provide a set of preset filters for social networks that publish on Twitter. We also provide soundex-like matching to stuff that would probably be published by other social networks that do not follow the rule of setting their source. There are some of those out there, right? And but the point is, we can't tell you what is relevant and what is not in this whole amount of content here, because that will depend a lot on the kind of message you're trying to send on your forged content. So we actually thought about that a lot, and we couldn't find a way of, say, creating a filter that would work for at least 2/3 of the people who we thought could be using the application. So we decided that for this initial version, we won't try to be to make this like a wizard-like thing where you press next, 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 and it would spit out a phishing message at the end for you. Pretty much because that's beating the Turing test, right? We know we can't do that, and also because this is not meant to be used we don't want to write another script kiddie too. That's really pretty much it. We don't want this to be something that can be used without giving consideration of what you're trying to do. We need you to understand what the tool can be used for, and want you to know what kind of content you're looking for when going through a set of tweets from an unsub, okay? So we have the numbers here. There are 290 tweets that mention beer. And when you do that, oh, awesome. Okay, so this is because we're offline, and what's happening here is that we'll try to contact Twitter in order to do some validation. We are offline here, the validation will fail, so sorry about that. What happens here is that every time we touch the Twitter account of someone, we will actually reach back to Twitter to validate that's working. So, but the point is, when you start a profile here, that will trigger the execution of a background job that will do the actual processing. When you finish a profile, as we saw here, no, this thing is too big. Let me get a smaller one. Okay, this one is a smaller. This is actually the kind of data structure we get in the back end. So here you can see that we have the words, we have these are called POS tags, and they will show you what kind of word this is, if it's an adverb, if it's a proper noun, an adjective, stuff like that. The idea is that we will eventually introduce machine learning into this thing so that we can do partial analysis while we're writing content in order to evaluate if, for instance, you are using a word in the context of a noun, of an adverb. Today, the dictionary does not take that into consideration. But the idea is that we need to add some kind of support of machine learning to this thing so we can do partial NLP analysis while the user is still building the sentence. Because as of today, if I get that thing that you were writing on the text input, send that to treat for NLP analysis and get the result back, and it won't work because the sentence isn't complete, right? Okay, so going back. Oh, you've seen the demo already. So, what are the limitations? First, Twitter only allows us to fetch the latest 3,200 latest tweets from a given user through their official APIs. For a regular person, that means around 2 years worth of tweets, right? But for some people, 3,000 tweets is too little because they will tweet, by the minute. So this is something we cannot get over. This is a limitation of the official APIs. The only way of getting over that would probably be through scraping, and we already mentioned the limitations of scraping. We didn't want to do that at this point. Second limitation is partial NLP analysis. We already mentioned that. We can't do that while we're writing the content. So we can't actually get that thing that you are writing, which has partial words on it, which is not really a complete sentence, throw that to our backend engine and have it actually understand what each word in that sentence is without having the complete thing. It doesn't work like that. Third thing is the interface itself. And I'll show you guys the actual back end of this thing so you can understand how powerful the engine is. So for instance, one thing we don't have in the interface today is, let me just, Luis, sorry for using you so much as a guinea pig, but so here we have, for instance, the kind of attributes available on a tweet for us to filter on. So we have, for instance, the text, the source, if it was in reply to someone else, the user that wrote it, right? You also have what we call entities. Entities will include URLs included in the content, hashtags, and user mentions. That's why we were able to do the filtering on the text. But we can throw that content away and have it in the metadata that Twitter sends back to us. This is the kind of thing that we really wanted to be able to provide you in the interface. But again, as I said, due to my lack of design skills, I couldn't find a really nice way of making this kind of flexibility in the query be made easily done on the web interface. Here they are, the URLs, the user mentions. Right, so for instance, this is like the oldest tweet in our database by Luis and the newest one by Luis, the dates from those. This is really easy to obtain if you know. Okay, this is really unreadable, sorry about that. So this is like, okay, I want the minimum value of the created ad attribute for the status attributes of the FN data source, the max value, and I can be as flexible as some say something like this. That's basically a query that will get anything that mentions TrustWave in a case-insensitive match, which were published in the latest 120 days. Right? So what I wanted to show with you is this. The backend is way more powerful than what the interface allows you to do today. This is mostly due to my lack of web interface skills. And that's one of the main reasons also we want to release this thing as open source. We want people who are better than us at user interfaces to be able to contribute so that this kind of flexibility is made available in the interface. Building presets, building rich interfaces that would allow you to construct these kinds of queries in an easy way so that you can have profiles which are as tailored to your needs, as finely tailored to your needs as possible, is something that is really above our design skills today. So finally, and where do we want to take this thing? First and foremost, support for additional data sources, right? One of the things we're not doing today, and which is very much of interest to us, is toying around with the concepts of clustering so that we can, for instance, see the way and profile the way you talk about certain topics on some social networks. So when you're talking, say, about information security on Twitter, you would have this dictionary, you would have this kind of writing style, and when you're talking about information security on LinkedIn, you would have a different set of words, a different set of writing style and stuff like that. This is actually kind of easy to do with the support we have in the backend today, but we didn't want to add additional variables to the system at this point because, as I said, different data sources, different intentions in the users behind those data sources, and we wanted to focus only on tinkering this for Twitter for initial proof of concept, right? Second, as I mentioned, machine learning, more metrics, better feedback. You probably understood when I said what those numbers mean on screen, but if I didn't tell you that, the interface itself would not. So we want for you to be able to understand better what those numbers mean, so you can actually modify the way your writing style goes so that it better fits what the application expects. Filtering presets, already mentioned that. And this one is particularly hard, adequate handling of quoted content, which is like, how do you identify content that mentions someone else inside the timeline of an unsub, right? So when we're quoting someone, you have to know when the quote starts and when the quote ends, because everything else is content we're interested in. And I think that's it. I think we pretty much nailed the time, so I'm quite happy about it. As you can see, it's a very much work in progress, right? We are really, really, really open to suggestions and criticism. This thing, we started it thinking it would be easy to do, but there were, as always, devil is in the details. If you check out the code and look at it, you will see there's a lot of edge cases out there that we are already trying to handle, and that does not even include the limitations we discussed here. So we want, we are very, very open, really, to criticism and suggestions regarding the tool. And I think that's it. Alguma coisa? So I'd like to thank you.